Bismillahirrahmanirrahim. Hello, my dear cute baby students. How are you? I hope you are all doing well. My name is Azmat Ali, and I welcome you all at my channel Universal Math Zone. We are discussing our lectures on O-level mathematics. Lastly, we discussed topics on test of divisibility, prime numbers and composite numbers, different types of numbers, and sieve of Eratosthenes, primarity test. How can you find the given number is prime or not? In today's lecture, we are going to start exercise 1A, and the book that I am using here, this is the Think New Syllabus Mathematics 8th edition. This is a good book, and this book is very nearly close to your final exam of O-level mathematics. So in this lecture, inshallah, I will try to complete this exercise 1A. So let us start our discussion from question number 1. The question number 1 states that determine whether each of the following is a prime or composite number. We have some given these four numbers, and we have to check which of the number is composite and which is prime number. To understand today's lecture, you should have to idea about test of divisibility and primarity test. I will revise all of these things during our discussion. The first important thing is that even number cannot be prime. There is only one number that is even and it is also prime. This is 2. All the other numbers which are prime are all odd. So here all of these four numbers are odd. So this is possible that all of these could be prime numbers. So let us check all of them one by one. We start from 87. 87. Clearly this is odd number, so it is not divisible by 2. A prime, you know what is, how can we define prime number? A number is called prime number if it has only two distinct divisor, one and itself. So if 87 is a prime number, then it should have only two distinct divisor, 1 and 87. If there exists any other divisor, then it will be not a prime number. So we apply the divisibility test. 2 cannot divide 87 because 87 is odd number. Further we check, is this number is divisible by 3? Yes, this number is divisible by 3. What is the divisibility criteria of 3? Divisibility criteria of 3 that we say we add the integers, we add the digits of this number. This gives 15. As you know, 15 is divisible by 3. This implies 3 divides 87. So 87 is not a prime number. This is a composite number. This is composite number, and clearly you can observe, see that 87 can be written as 29 into 3. So this shows that 87 has a 4 divisor, 1, 3, 29 and 87. Next is number is B is equal to 67. 67 is clearly not divisible by 2. It is also not divisible by 3, because if you add the digits of this sum is 13, and 13 is not divisible by 3. This shows 3 cannot divide 67. Because this is an odd number, so any even number cannot divide these numbers. So we will not check the divisibility of this number by 4, 6, 8, 10, etc. Next we move towards 5. Is 5 divided 67? No. because the last digit is not 5. That's why this number is not divisible by 5. What is the criteria of divisibility of 5? A number is called divisible by 5 if its last digit is 0 or 5. Its last digit is 7, which is neither 0 nor 5. That's why 67 cannot be divisible by 5. Is this number is divisible by 7? No. In the table of 7, you cannot find this number is not divisible by 67. Is this number is divisible by 11? No. There is a no number in the table of 11 where you can find 67 appears. No, this no. 13 also does not divide 67. So if we apply the primarity test or square root test to check whether this number is a prime or not, this is very simple. You have to find a perfect square. You have to find a perfect square which is nearly close to 67. 8 square. 8 square is 64 and 64 is less than 67. So this number 64 is a perfect square. This is a square of 8, which is close to 67 but less than 64. Now the primarity test says we will take its square root of 67. This is equal to 8. Now we find all the prime numbers which are less than or equal to 8. All the prime numbers which are less than or equal to 8 are 2, 3, 5, 7. This is very simple. Now you have to check only the divisibility of 67 for these 4 numbers. There is no need to check the divisibility by 11, 13, 17, etc. 2 does not divide 67, 3 does not divide 67, 5 does not divide 67, 7 does not divide 67. This implies 67 is a prime number. So this is very simple. This criteria says you have to find a number which is a perfect square, which should be perfect square but less than this number. Now you have to take square root of that number which is a perfect square. So the square root of 64 is 8. Now you have to write all of the prime numbers which are less than or equal to 8. So the prime number which are less than or equal to 8 are 2, 3, 5, 7s. Neither of the number divides 67. That's why 67 is a prime number. The next number is 73. The next number is 73. C part. The number that is a perfect square and nearly close to 73. 8 square is 64 and 9 square is 81. 81 is a larger than 73. Then again we will use this number. 64 is less than 73 and 64 is a perfect square and square root of 64 is 8. So all the prime numbers which are less than 8 are 2, 3, 5, 7 again. And now check which of the number 2, 3, 5, 7 divides 63. 2 cannot divide 73 because 2 is even and 73 is odd. Even number cannot divide odd number. So this number is not divisible by 2. Is this number divisible by 3? Divisibility of 3. What is the criteria of divisibility of 3? We have to take sum of the digits of this number. This is equal to 10. Is 10 divisible by 3? No. This implies 3 does not divide 73. Similarly, 5 does not divide 73. Lastly, 7 also does not divide 73. This shows this is also a prime number. My last number is D, which is equal to 91. 91 clearly it comes in the table of 13. Otherwise, you can use again the I am just writing here 91 is a composite number because I have to done the remaining questions also. So it will take time otherwise. This is a composite number because you can observe that 91 is simply 13 into 7. So this shows that 91 is not a prime number. The similar exercise of this question number 1 is question number 7. Otherwise, in your book, you can see the same questions are practice now 1. Question number 1 in the exercise and question number 7. Question number 7 is interesting question. The statement of question number 7 says, find all the prime numbers in each of the following decades. Decades means a series of 10 years, consecutive 10 years. Uh, the first one decade is 2011 to 2020. You have to check which of the year is the prime number among these decades. Remember that there is a no direct short trick to identify which of the number is a would be a prime number among these number. But this is my observation that among in these 10 years, among the any decades, there will be one to two prime number. It must be that there will be one to two prime numbers. So now we check which of the here is a prime numbers. Clearly, all of the even numbers cannot be prime numbers. So remove all of the prime numbers, even numbers. So 2012, 2014, 2016, 18, 20 cannot be prime. Cannot be prime. The next one, 2015 is also not a prime. Cannot be prime. Cannot be prime. Cannot be prime because the last digit is 5. So this number 2015 is divisible by 5. This shows that this number cannot be a prime number. Now the remaining years are remaining years are 2011, 2013, 2017 and 2019. Now we have 4 remaining years. Now we check, is there any number which is divisible by 3? The criteria of divisible by 3 is very simple. Sum the digits. If you sum the digits here, 3 plus 1, 4, 4 plus 2, 6. 6 is divisible by 3. It means 3 divides this number. So cross out this number also. This cannot be divisible by, this is a composite number, simple. 9 plus 1, 10, 10 plus 2, 12. This is also a composite number because it is also divisible by 3. Now we have only 2 remaining years. The 2 remaining years are 2011 and 2017. The answer is actually these are both prime numbers. These are both prime numbers. But can we say directly these two are prime number? No. There is no shortcut technique to say these two are prime. It is possible that there exist some prime numbers that divide both of these. So what is the criteria? Again, the criteria is same here. We will find a perfect square which is nearly close to 2011, and we will find all of the prime numbers which are less than that perfect squares. If anyone divide these numbers, then this will be not a prime number, otherwise these are prime numbers. So you can, this is your exercise, your assignment. You have to find any whole number which is a perfect square. This can be done very easily. You will take its square root, 2011. The square root will be in a decimal form. So take its integral parts. Now you have to find all of the prime numbers which are less than or equal to that integral part. If any prime number like this divides this number, then this number is not a prime, otherwise these are prime. But the answer is that these both are prime numbers. The second part is in this B part, the decade is 2021 to 2030. You can do this question by yourself by the same procedure. So question number 1, question number 7, and your practice now 1. These are same. Now we move towards our is its second topic. This is actually problem involving prime numbers, and these are practice now 2. In practice now 2, our next topic in this book is our next topic is actually problem involving prime number, and this topic involve practice now 2, practice now 2, and question number 2, 3, 8 from exercise. Now we discuss each of the question one by one. Question number 2. The question number 2 says, if P and Q are whole numbers such that, question number 2, if P and Q are whole numbers such that P cross Q is equal to 37, find the value of P plus Q. Find the value of P plus Q. P and Q are whole numbers. As you know, 37 is a prime number. It means 37 has only two distinct divisor, two distinct factors, 1 and itself. It means you can take either P is equal to 1 and Q is equal to 37. 1 into 37, this is equal to 37. Or you can take P is equal to 37 and Q is equal to 1. Again 37 into 1, this is equal to 37. So it means in either case your sum is P plus Q is equal to 1 plus 37, this is equal to 38, or 37 plus 1, this is also equal to 38. So your sum is 38. But if this number is not a composite, this number is not a prime number, this is a composite number, then you have to find all of the factors. Like for example, the number is 12. Then you have to make all of the factors of 12. The first factor is 1 into 12, second is 2 into 6, 6 into 2, 3 into 4, 4 into 3. Then there are more than one answer. So you have to judge this very carefully. The number on the right side is prime or composite. At this time, this number is the prime numbers. That's why there is only one possibility. Our P is 1, Q is 37, or P is 37, Q is 1. But in both cases, your answer is 38. Next one is question number 3. Yes, this is also very interesting question. Question number 3. Question number 3. Question number 3 states that if n is a whole number, your n is a whole number, your n is a whole number, such that n cross n plus 42 is a prime number. This is a prime number. This is a prime number. Find the prime number. You have to find that prime number and explain your answer. This is an interesting question. From this product, visually it seems that this number is divisible by n, this number is divisible by n plus 42, this number is divisible by itself, this number is divisible by 1, but he mentioned that this number is the prime numbers. It means this complete number has only two divisor. 1 and itself. This is divisible by 1 and itself. It means if it is divisible by 1, then this is possible that your n is 1 here. Otherwise, if you take n is equal to 2, suppose if you take n is equal to 2, then what will be the answer of this number? The answer of this number will be 2 into 2 plus 42. This becomes 2 into 44. Clearly, this number is not a prime number because this is the multiple of 2, that is even number. If some student says, sir, can we take n is equal to 3? No, this is not possible. If you take n is equal to 3 here, this becomes 3 into 3 plus 42. 3 plus 42, sorry. Again, you can observe that this is 3 into 45. Again, this number is multiple of 3, clearly divisible by 3. So there is a no option. If you want this number should be a prime number, there is a no option other than 1. So you can only just plug in here n is equal to 1. Otherwise, whatever you put n, the complete number will be the multiple of that n. For example, if some student put here n is equal to 7, the complete number will be multiple of 7. In that case, this will be not a prime number, because prime number is only has a 2 factor. 2 factor mean it always divisible by 1 or itself. So to divide it by 1, we just take n is equal to 1 here. So when you take n is equal to 1 here, this becomes 1 in cross 1 plus 42. So your number is 43 into 1, that is 43. This is your prime number. And this number work for n is equal to 1. Next one is question number 8. Question number 8 is very simple, and this question is similar to question number 2 here. In this question number 8, if a and b are a whole number such that a cross b is 2027, a cross b is 2027, you have to find the value of a plus b. In this question, the difficulty is only, is 2027 prime or composite? You have to check whether this number is prime or composite. This number is a prime number. So similar to this question, your a, if your a is 1, then your b will be 2027 and your answer is 2028. That's complete the question. Next one we move towards practice now 3, and now our topic is prime factorization. Okay. Our topic is index notation and prime factorization. Our next topic is topic number 3, index notation and prime factorization. And this includes practice now 3 from this book, and from exercise you have to done question number 4A, 4, complete question 5, and question number 9, 10. 9, 10. So this topic has a 4 question. Okay. Let us discuss question number 4. Find the prime factorization of each of the following number, leaving your answer in index notation. Your first number is 72. We start with a simple example. Your number is 72. You have to make its prime factorization and leaving your answer in a index notation. We will use a division method to make its prime factorization. As 72 is a even number, so it must be divisible by 2 here. So when you divide 72 by 2, 2 3 is 6, remainder is 1. So the next number becomes 12. This is 2 6 is 12. 2 18 is 36. 2 9 is 18. Next number is divisible by 9 is divisible by 3. 3 3 is 9. 3 1 is 3. So the prime factorization of 72 is simply 2 into 2 into 2 into 3 into 3. As 2 appears 3 times, so we can write it as 2 raised to power 3. And 3 appears 2 times, this can be written as 3 raised to power 2. So this is my index notation and this is the prime factorization of 72. Next we do its B part. Second part is 756. 756. We have to make its prime factorization. I think you can do all of these parts. B is 756, C is 187, D is 630. I do 187. C parts. It seems some difficulty. 187. 187. This number is not even number, so it cannot be divisible by 2. Is it divisible by 3? No. 8, 7, 15, 15 plus 1, 16. 3 does not divide 6. It means this number is not divisible by 3. We cannot take 4 because 4 is not a prime number. We have to make prime factorization. So we will always choose a prime number for division. Is this number is divisible by 11? Yes. This number is divisible by 11. 11 ones are 11. Remaining is 7. This becomes 77. 11 7 7 is 77. 17 is clearly divisible by itself. 17 is 17. So 187 can be written as 11 into 17. As both of the number appear only one times, so this is the final index notation. Now we move towards its question number 5. Yes. Question number 5 is an interesting question. But for just a minute, please. Okay, next we discuss question number 5. Question number 5 has the 2 parts. In the first part, express 2026 as a product of its prime factors. We have to make prime factorization of 2026. We will use division process. Clearly this number is an even number, so it is divisible by 2. So when you divide it, 2 times are 20, 2 1 the 2, 2 3 is 6. Next, the next number is 1013. Is 1013 a prime or composite? This is a prime number. Is there any trick? No, there is no trick. As an experienced teacher, I know this is a prime number. But as being a student, how can I guess this number is a prime? I will use the primality test. This is simple answer. You will take its square root if calculator is allowed. Otherwise, you will find a number whose square is nearly close to 1013. The number whose square is nearly close to 1013 is 31. 31 square is 961. 961 is close to 1013 but less than this. Otherwise, square of 32 is greater than 1030. Now I have to take all of the numbers, all of the prime number which are less than 31, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and last one is 31. And one by one I have to check, is any of the number divides 1013 or not. If all of the numbers do not divide 1013, then 1013 is the prime number. You can check easily by using test of divisibility. The actual answer is this is not easy to divide this number by all of these without calculator especially. The fair answer is that this is not easy, but if calculator is allowed, then this is very easy. You can simply divide 1013 by all of these number, and you can check none of the number divide to 1013. That's why 1013 is a prime number. So the prime factorization of 2026 is 2 into 1013. What is its B part? Second part, sorry. Given that A and B are the whole numbers such that A is less than B and A cross B is 2026. Next is A cross B is equal to 2026, but A is less than B, should be less than B. Write down all the possible pairs. You have to write all the possible pairs AB that satisfy this product, but A should be less than B. So one of the possible pair is this, as 2026 can be written as 2 into 1013. So from this product, my A is 2 and my B is 1013. Clearly 2 is less than 1013. So one of the pair is 2 and 1013. Is there any pair, any other pair? Yes, the other pair is 2026 is equal to 1 into 2026. Now my A is this and B is this. So the other pair is 1, 2026. Can we not take this pair? We can take this pair, obviously, because there is no condition that A and B are prime number. The condition is that A and B are a whole number. If he says A and B should be prime and less than B, then there is one possibility, 2 and 1013. But he says A and B are whole numbers. So we can take both of the pair. So there are two answers of this question. The next one is question number 9. The question number 9, find the prime factorization of each of the following numbers, leaving your answer in DAX notation. The same, criteria is same, but now the numbers are bigger than question number 4. I do one of the part, question number 9, D part. The number is 196,000 and we have to make its prime factorization. My number is 196,000. 196,000. Clearly number is even, so it will be divisible by 2. You cannot divide it by 10 because 10 is not prime. You have to make its prime factorization, so you will start from any prime number. Although you can take here 5 directly, this number is divisible by 5 also. So if we start by 2, 2 9s are 18, 2 8s are 16, and becomes 98,000. Again we divide by 2, this becomes 2 4s are 8, 2 9s are 18, now number is 49,000. Again it is divisible by 2, 2 2s are 4, and 2 4s are 8, 2 5s are 10, 0. 2 1s are 2, 2 2s are 4, 2 2s are 4, 2 5s are 10, 0. Again it is divisible by 2, 2 6 are 12, 2 1s are 2, 2 2s are 4, 2 5s are 10. Now it is not divisible by 2. Last digit is 5. Now it is divisible by 5 only. 5 1s are 5, 5 2s are 10, 5 2s are 10, remaining is 2, 5 5s are 25. The last digit is also again 5, again it is divisible by 5. So 5 2s are 10, 5 4s are 20, and 5 5s are 25. 5 4s are 20, 5 9s are 25. Now it is divisible by 7, 7 7s are 49, 7 1s are 7. So this is the complete prime factorization of this number. So you can write this number as, in the index notation, clearly 2 is repeated 5 times. 1 2 3 4 5. So 196,000 equal to 2 raised to power 5. 5 is repeated 3 times and 7 is repeated 2 times. So this is its complete prime factorization. Now I hope you can do all of the remaining questions. The next one is question number 10. The question number 10 is same as question number 5. Given that x and y are the whole number such that x is less than y and x cross y is 2022, write down all the possible pairs. Okay, question number 10. My number is 2022. Given that, question number 10, x cross y, this is 2022. We have to find all the possible pairs x comma y such that x is less than y. X should be less than y. What will we do? Firstly, we will make its prime factorization. Then we see next. What is its prime factorization? 2 1s are 2, 0, 2 1s are 2, 2 1s are 2. Is this number is divisible by 2 next? No. Is it divisible by 3? Yes. If you sum all of the digits 1 plus 1, 2, 2 plus 1, 3, 3 is divisible by 3, it means this number 1011 is divisible by 3. 3 3 is a 9, 3 3 is a 9, 3 7 is a 21. Is this number again divisible by 3? No. 7 plus 3, 10, 10 plus 3, 13. 13 is not divisible by 3. Is this divisible by 7? 7 4s are 28. Remaining is 5. The next number becomes 57. 57 does not come in a table of 7. It means this number is not divisible by 7 also. Is this number is divisible by 11? No. This is a prime number actually. So this number is actually prime number. Further, it is divisible by only by itself. So you can write it as 2022 has a prime factorization 2 into 3 into 337. Now you have to make all of the pairs where x and y are a whole number. X and y are not a prime numbers. There is no condition of x and y is a prime number. Now see carefully. The first pair is, if you consider this is the first number, 2 3 is 6. 6 into 337. This is my x and this is my y. So the first pair is 6, 337. This is my first pair. If I consider 2 as the first number, Then the second number is product of 337 and 3. What is its product? This becomes 3 sevens are this is equal to 1011. 3 sevens are 21, 3 is 9, 9 plus 2, 11, 3 is yes. The second number is 1011. We have to make all of the possible pairs for which x is less than y. First number should be less than y. There is a no condition that the first and second number are a prime numbers. So if you take 2 into 3, this is the first number, then the second number will be 337 and 6 is less than 337. If you consider 2 as the first number, then the second number will be 3 into 37 and product of 3 into 37 is 1011. The second pair is 2 and 1011. If you consider the first number is 3, then the second number will be 337 into 2. What is the 337 into 2? 2 7 the 14, 2 3 the 6, 7, 2 3 the 6. The second number is 674. And the last one is, the last pair is also possible. If the first number is 1, then the second number is 2022. Yes, these are the 4 possibilities. These are the 4 possibilities for which x is less than y. And this completes our topic number 3. Next we move towards topic number 4, and this topic is very, very interesting. This is the key bone of total lecture. So we discuss next topic, last topic of this lecture. Okay. Next we move towards the last topic of today lecture, and this is very interesting. This topic is problem involving prime factorization. The similar question related to this topic are problem practice now 4 and question number 6, 11, 12 in the exercise. I will do question number 11 and 12. Question number 6 is very easy, and I hope you can do this question by yourself similarly as I will do. Question number 11. Before going to start this question, you have to understand the concept of cube and cuboid. Actually, these questions are related to cube and cuboid. You know, cube and cuboid both are the 3D objects. In case of cube, you know, all of the dimensions, its length, width, height are all equal, and its volume is given by length into width into height, where length, width and height are all equal, so volume just becomes L cube, simple. But in case of cuboid, you know, our figure is rectangle, base is rectangle. This is also, cuboid is also a 3D object. But for cuboid, any of 2 dimensions, either length or width or height, or length or height, could be different. So, but volume is calculated by the same formula. This is my cuboid. Here length, width, height could be different, but here all of these are same. In case of cuboid, any 2 dimensions are different. In case of cube, all of the dimensions are same. Now I read the question. Question number 11. Ali wants to use 210 1 centimeter cubes to make a cuboid such that each of its side is longer than 1 centimeter. There are 6 possible cuboids that he can make. Find the dimension of any 3 of them. He says, the author says there are the possible 6 cuboids that he can make, but we have to find only 3 of them. Inshallah, I will find all of the 6 cuboids. Sorry, Ali has 210 cubes of dimension 1. Each of length with height is 1. he have to make by using this cubite. He says there are 6 possible cubite Ali can make. We have to find only 3 of them. So first of all, we will make a prime factorization of total 1 centimeter cubes are equal to 210. There are 210 1 centimeter cube. So firstly we make its prime factorization. This becomes 2 10s are 20, 2 5s are 10. This is equal to 5 to the 10, 5 1 the 5. This is 3 7 the 21 and last is 7 1 the 7. So the prime factorization of 210 is equal to 2 into 5 into 3 into 7. Actually, what does this question says? Actually, this question says that we have to take any 3 of numbers. These are 4 numbers. We have to convert these 4 number as a product of any 3 numbers, such that their product should be 210. For example, the first case is if my length is 2, I make here all possibilities. If my length, this is my length, width, height. If my length is 2, length is 2 and width is 5, then height will be product of these two. Height is 5, then width is 5, sorry, then height will be product of last two, because the volume of cube or cubite is cubite involve only 3 numbers, length, width, height. If you take first number as a length, second width, third one will be product of last two. 3 into 7 21. This will be your height. So this is the dimension of first cubite. Its length is 2, width is 5 and height is 21. Again, now if you take its length is 2, width is 3, then height will be the remaining 2, product of 2, 5 7 the 35. So this is the second case. Now if you take my length is 2 and my width is 7, this is my width 7, then what will be the height? Height will be the product of remaining 2, 5 into 3 15. This is my third pair. The demand is he demand only for 3 cubite, but we can find all of the pairs. Now if you start from 3, if my length is 3, if, my length is 3 and my width is 5, what will be the height? Height is the remaining 2, 2 7 the 14. If you take 3 7, 3 and 7, the remaining is 15. If you start now from 3 5 complete, we cannot take 3 and 2, because this pair is already we have written 2 or 3 or 3 or 2, these are same. If now we start from 5, we cannot take 2 5 5 2, so if we take 5 7, this is the last pair, 5 7, 5 length, which is 7, height will be 6. So these are the possible 6 cubite that Ali can make. Next one, question number 12. This is the same question, but there is some strong condition in this question. Question number 12. Question number 12. David. David uses 504 1 centimeter cube to make a cubite. Total 1 centimeter cubes are 504. There are 504 cubes whose dimension is 1 centimeter from each side. The perimeter of the top of a cubite is 20 centimeter. This is interesting. Perimeter of top of of the cubite is equal to 20 centimeter. David have to make cubites, but the condition is that the perimeter of the top of the cubite should be 20 centimeter. Understand this carefully. Okay. Firstly, we make a cubite. This is my cubite given that David make. Its name is A, B, C, D, E, F, G, H. This is the vertex of the cubite. What is its top? Its top is the rectangle EFHD. Top is given by rectangle EFHD. You know the perimeter of rectangle is given by 2 times length into width. Suppose we have to find, in this question we have to find height of cubite. Let height of cubite is H, which is given by AF, or you can say HB, or you can say CD, or you can say GE. All of these represent its height, and this is given by H. The FH, this side is length, and HD, this side is width. Top is a rectangle EFD. Perimeter of rectangle is 2 times length plus width. This is the formula of perimeter of rectangle, you know. This is equal to 20. If you divide both sides by 2, this gives L plus W is equal to 10. This is equation number 1. Now we make prime factorization of 504, and we will choose all of the numbers whose sum is 10 and product is 504. So firstly we make prime factorization of 504. 504. This is 25, 2 to the 4. This is 12 to the 24, 2 6 is 12. This is 2 6 is 12, 2 3 is 6. This is 7 9 is 63. This is 3 3 is 9, 3 1 is 3. So the prime factorization of 504 is given by 2 appears 3 times. So this is 2 cube. 3 appears 2 times. This is 3 square, and 7 appears 1 time. Next, I read the remaining question. The perimeter of the top of the cubite is 20 centimeter. Each side of the cubite is longer than 2 centimeter. Yes, this is the condition. In above question, there was the condition of each side should be longer than 1 centimeter, and in that question, you can see that each of the side, that is each of the number in the prime factorization, was greater than 1. Here, each of the side of the cubite is longer than 2 centimeter. Find the possible height of the cubite. You can observe that each of the number in this prime factorization is not greater than 2. These two numbers are greater than 2, but this number 2 is not greater than 2. So we will make the dimensions very carefully. How can we make its prime factor? We make its dimensions. Okay. Actually, from these 3 numbers, you have to choose two numbers whose sum is 10, whose sum is sorry 10. The possibilities are to make 10. You can choose 7 and 3. Your sum will be 10. Okay. You can choose 4 plus 6. This is also 10. But where is 4 here? There is a no condition that your height, your length, your width will be a prime number. There is a no. These numbers are maybe composite number. So where is 4 and 6 in this question? This is 2 cube. If you take 2 square from here, and this is 3, and one of the two, if you attach, if you write this number as 2 into 2, 3 into 2, and 3 into 7. One of the 3 we attach with 7, one of the remaining 2 we attach with 3. Now this is 4, this is 6, 4 plus 6, 10. That completes the condition 1, and the remaining is 21. Now we make all height of the cuboid. Okay. This number can be written as 2 square into 2 into 3 into 3 into 7. If this is my length L, and 2 into 3, this is 6. Further you can write it as 2 into 2, 4, 2 3 the 6, this is 21. If you take this is my length, this is my width. So it completes the first condition, L, length plus width, this is 10. So this will be height h. In this case, you will write, if cuboid has dimensions 4, 6, 21, this implies height is 21. There is another possibility to make 10. This is 7 plus 3. Now can you break this product as 2 cube into 3 into 3 into 7. We attach one of the 3 with 7. This becomes 2 into 3, this is 8, this is 3, this is 2 3 the 8, 8 3 the 24. 24 into 3 into 7. If this is my length, this is my width. L plus W, this is 10, and this will be my height. The second possibility for the cube, dimension of cube are 3, 7, 24. This is length, this is width, this is my height. The similar question you can find in a practice now 4. So with a great effort, I have Alhamdulillah complete this exercise. If you find this lecture helpful anyway, kindly like, share and subscribe my channel. See you in the next lecture. In the next lecture we will discuss very important topics, square roots and cube roots. So take care. Allah Hafiz.